Hello, everyone. I'm Joe Pryweller, Director of Conference and Event Content for the Crane Global Polymer Group. Welcome to this session of Ask the Expert. These sessions are your chance to engage live with professionals on a range of topics and interact with questions. Today's Ask the Expert is sponsored by Rapid Robotics. Our expert today is Jordan Kretschmer, co-founder and CEO of Rapid Robotics. In this session, Jordan will introduce innovations from Rapid Robotics and provide videos that show how companies are solving their machine operator shortages. Jordan will answer your questions after the presentation. To submit a question, email pnevents@crane.com. Or if you're watching along on LinkedIn, Facebook, or YouTube, you can submit a question via those platforms. With that, I will turn things over to Jordan Kretschmer of Rapid Robotics. Jordan, the floor is yours.
Hi, everybody. Thanks for having me. So today we're going to be talking about the machine operator shortage that exists not just in the US, but globally, and how it's impacting the manufacturing market. And also, most importantly, what Rapid Robotics is doing in order to help manufacturers solve this labor shortage with the solution that we call the Rapid Machine Operator. Or the RMO. So the Rapid Machine Operator is the first all-inclusive, out-of-the-box robotic machine, robotic arm that comes with everything that you need to operate mostly secondary operations and any simple and repetitive tasks that tend to be the tasks that take up a vast majority of your human capital on the floor, so that those human operators can be redeployed to higher value, more complex tasks in order to help fill this labor gap. And the reason this is so important is because the labor shortage that we're experiencing today is only the tip of the iceberg. This has been getting worse and worse over the past decade, to the point where today we actually have just under 1 million unfilled machine operator positions in the US alone. And all accounts say that that's going to about 2.2 million people by 2025. So that's a massive shortage in terms of our capacity in the US to be able to produce all of the parts and components that go into the products that are being purchased out in the market. And so all of this is happening while 98% of manufacturers still do not have robotic arms. So robotic arms these days are still relegated to really just the top 2% in size of manufacturers out there. And there are certain segments that is really focused on. And all of this is happening while labor rates are increasing. The amount of time it takes to hire operators is going up. Operator turnover is at the highest rates it's ever been. And so all of that, again, with 98% of manufacturers not having robotic arms, the numbers are actually pretty stark. So if you go back to about 30 years ago, when robotic arms became mostly commercially available, you had about 25 robots per 10,000 workers. And in 30 years, that has only gone up to about 200 robots per 10,000 workers. And the main reason that most manufacturers don't have a single robotic arm in their facilities is a concept that I call automation disillusionment, which is this historic barrier to automating that's made up of 4 components. And I'm sure most of you have actually experienced plenty of this along the way if you've tried to automate. And so about 80% of the tasks that exist on a factory floor could be automated with a robotic arm, but because of these 4 things, it's not able to be. So the first and foremost is exorbitant costs. While the cost of the hardware, the robotic arms, has come down dramatically in the last 5 years, the cost of hiring and working with a systems integrator to bring in the expertise to buy all of the separate components required to make a robotic arm work have gone up dramatically. So the average robotic arm installation is around $450,000. And then it can go up in some cases to over $1 million for a single robotic arm to be deployed against a simple task. The second is the unmanageable complexity of this. So very, very few facilities have in-house expertise for dealing with robotic automation specifically, and all of the issues that can come up with robots. And so the idea of spending an enormous amount of capital and then not being able to really manage and oversee that yourselves has become another barrier. The next one is the complete lack of task flexibility. When you install a robotic arm and you've manually programmed it over the course of 4 to 6 weeks to do that specific task, you can't move it again unless you want to pay for a reprogramming fee to have it reprogrammed for another thing. So unlike a human operator that you can train very quickly on a new task and move between machines throughout the day, a robot does not have that flexibility. And then the last part is the go live can take forever. By the time you engage a systems integrator, you decide on all the different components that you want. You purchase those components through the SI. They schedule for the deployment. It can be months before you actually have that arm there to fill that labor shortage. And so at Rapid Robotics, we focused primarily on the business problems surrounding automation. Instead of focusing on making a better end of arm tool or making a faster arm, we work with existing hardware that is highly reliable, that's been in the market for decades. And we build on top of that, or underneath that, a software system that has AI, computer vision, intelligence, that's making decisions about how to interact in a work cell. And it is, as a result of that, the first ever flexible robotic arm that can actually be moved between multiple tasks over the course of a day, week, or month with no reprogramming at all. And the whole system is a no programming system. The cameras that are associated with the arm make the decisions about where the arm needs to go using what it's seeing in the work cell. They come ready to work. Our standard integration when we come on site is 2 to 3 hours. And then we also offer full 24/7 remote and then on-site support in day shifts for maximum uptime. And so the entire goal of Rapid Robotics as a company is to support the fleet of robots at your facility so that you do not have to worry about the robots at all. We become almost sort of your outsourced contract resource to come in and deliver workers very, very quickly. And so while we're on site deploying in just 2 to 3 hours, we actually can make robot deliveries. Once the contract is signed with us, we can be on site in 1 to 2 weeks doing a deployment at its fastest. So the pricing model is a really important part of this, making sure that it's incredibly affordable. So getting rid of the huge CapEx expenditures that happen when you're working with a systems integrator, where they're coming in and you're spending $400,000 or $500,000 up front, and then plus maintenance and support fees anytime you need them to come back in. Our model is all inclusive. Every single thing, the cameras, the arm, the base structure, the safety structure, the computer that runs our AI, everything comes with the Rapid Machine Operator. And in the first year of operation, it's $3,750 a month, which is about $45,000 a year. And if it's working 3 shifts, the effective labor rate of the Rapid Machine Operator is only $5.20 an hour. And then every year after the first year, there's no setup fee. It's just the yearly recurring subscription fee of $25,000, which is also paid monthly at $2,100 a month, which if you're operating that arm 3 shifts a day, comes out to an effective labor rate of about $3 an hour. And so the next slide will be fairly obvious of what that means. So the human operator, this data is over 10 years at an average labor rate of about $28, fully burdened. Over 10 years, the human operators running 3 shifts on that one machine are costing about $2 million. A traditional systems integrated robotic arm that you pay CapEx up front, plus maintenance and support fees, plus any equipment replacement fees over the course of this period of time, comes out to about $1.3 million of total cost of ownership for a traditionally systems integrated installed robotic arm. Where Rapid Robotics, with our recurring pricing model, where everything, including support and hardware replacements and everything are included, it comes out to about only $290,000 over the course of 10 years. So that is an enormous savings, about $1.7 million in savings, or the way we like to look at it is immediate additional profit. And that's about $170,000 a year on average. So our customers today are driving anywhere between $80,000 and $200,000 a year of additional pure profit on tasks where they were previously driving between $5,000 and $10,000 of profit. And so again, this is for one task running 3 shifts, and that's how the data works out fairly objectively versus the cost of human labor. And like I've mentioned before, every single thing comes with the Rapid Machine Operator, all of the equipment needed to make this thing work out of the box. Our team comes on site, sets up the robot, does everything else needed in order to make sure the cameras can see the work cell. We apply the end of arm tool, the grippers, the fixtures. We train the operators on how to operate this. And all of the system runs from our iPad interfaces. There's 2 sides to the interfaces. One is the operator side, where the operators are just hitting start and stop. and then the other side of management that allows your team to be able to literally roll the Rapid Machine Operator to different machines, put on the new end-of-arm tool, open up our iPad, choose the program, and hit go without any reprogramming whatsoever. And as I mentioned, we are a full service company. So it's not just technology and the robotic work cell and the AI and computer vision. We are actually there 24/7. We can remote support almost every issue that comes up. And that includes any sort of operator issues or questions that come up during production. And everything we do is white glove, hardware replacements. We have local support teams in most regions, fully inclusive. Okay, so the next thing I'm going to do is hop out and share my another screen here. So pardon me while I get to the videos. Okay, I'm going to show a few examples of customers today who are utilizing the system to great effect. And so this first customer is a plastics manufacturer in the East Bay, California. They produce everything from medical devices to consumer packaged goods. This product here in this program is for a consumer packaged good. It's a coffee maker. We actually have Rapid Machine Operators in a number of places in this facility. 2 of those places are actually working on different parts of the production process for this product. So this program is a heat stamping program. The interesting things about this are when these parts are coming down the conveyor to us, they're oriented differently because they're being dropped from a Cartesian robot out of the mold. This is where our camera system comes into play. A typically, traditionally systems integrated installed robot without a vision system would not actually be able to execute this task because the way the parts are coming to us is slightly varied. Our vision system that is pre-built in and comes with the system can identify those subtle variations in orientation and automatically adjust its waypoints and adjust how the arm is actually interacting in order to get a perfect pick on the part every single time and get it flawlessly into the heat stamper. Another heat stamping task, since we're on the topic of heat stamping. So this is a manufacturer of the category of Frisbees based in the Midwest. And these 2 robots, our customers typically name our robots. This is Buck and Doe, named for their awesome antlers. And Buck and Doe, for a number of months now, have been hot stamping logos for this company onto the discs and then placing them on a conveyor to dry. So in each of the tasks I just showed you, the Rapid Machine Operators, in the first task, the one Rapid Machine Operator was replacing 2 human operators for a net profit every year of about $125,000 for that one robot installation. This was a replacement of 2 operators per shift over 3 shifts with just 2 robots. So that's savings of around $200,000 annually from 2 robots replacing the 6 humans over 3 shifts. So this next one I'm going to show is a very different use case. So this is an electronics manufacturer producing raw materials for circuit boards. And this is a great example of the variability that our system can handle using the cameras. You see here, one of the things that we do, I should mention, is we do custom create the end-of-arm tools for each task that are specifically designed for the parts we're interacting with. We do this to get 100% quality and to have the reliability of the deployment be absolutely as strong as possible. And so you see here, this is the craziest end-of-arm tool we have ever developed, because this customer needed this end-of-arm tool to handle 14 different sizes of material, ranging from small 4x4 pieces of copper for the circuit board all the way up to 14x20. And so our system, the cameras are actually looking at the fixture, holding the parts, holding the material. And when it sees the size of the material, it makes the determination of what parts of the end effector to activate in order to perfectly get to that material, no matter what the size is, pick it, place it into the machine processes it and hands it off to robot 2, who is then also activating the same parts of the gripper, all automatically, no program changeovers, no reprogramming at all. They can put 4x4s down, and then the next run, they can put 14x20s down without making any changes whatsoever. And our system adapts to it and automatically handles those changes. Let's see. So the next one, this was an example of a very, very simple. This is an example of we get on site and within an hour we are off site and it's producing production parts. So this is an air cleaning step for the backings for semiconductor chips. And there's not really much to say about this one. This is one of the most basic integrations that we can do. But instead of having, and there's actually two RMOs, two robots producing the same, doing the same task, but the two humans times 3 shifts. So 6 people a day that were just picking up little pieces of plastic and passing them through an air cleaner. That's 6 operators that facility was able to reallocate to different, much higher value tasks around their facility. Another thing that we do a lot of is quality inspection. So we actually have a very close partnership with a quality inspection company called Elementary Robotics. You see our interfaces on the left, theirs on the right. Our systems work together to automatically identify defects that can be almost microscopic, in metals and plastics and circuitry. And between our two systems, we can make determinations, red or green. We can make sub-determinations of that, where the arm automatically does something with the part based on the inspection that's happening. So the last one I'll show you, since I think I've given you a pretty good variety of the kinds of things we work on. This is another example of working with PCBs, where this applies to any time we need to actually interact with an assembled product versus we are interacting with a product, processing it through a pad printer or a hot stamper or an ultrasonic welder or taking parts out of an IMM. We can also do things where the arms themselves are interacting with the components, and in this case, in a very surgical way. So on this component, a motherboard, this used to be 2 human operators, one standing on each side of the motherboard, making a tiny, tiny little adhesive application to each of the pins on the circuit board. Took about 45 minutes per cycle with a rework of about 20% because of the human error involved in 125 pins with the accuracy needed in order to hit production quality requirements. And similarly here, almost every board they put in front of us is slightly different. We use CAD files in order to read what kind of board this is, to direct the arm to the correct waypoints and make sure that all of the waypoints are being hit, no matter what the configuration of the board is. Okay. And so those are just a very small few of the examples of the variety of kinds of tasks. Hopefully gets your brains going on the diversity of things that the system can do, and also hopefully get you thinking about what exists on your floor. These are the kinds of things that tend to be, very, very low profitability tasks, very, very low margin, almost, things that you've got to do as secondary and tertiary operations in order to get your customers to continue maintaining their relationship with you, to produce as many components as possible, where Rapid can help turn those into massive profit centers. Again, taking profitability on these tasks from $5,000 to $10,000 annually to the hundreds of thousands of dollars with a single robot. And so now the next thing I want to show you is what it looks like to move a Rapid machine operator between 2 different tasks on your floor. And so I'm actually going to skip over this first part. I'll talk about it really quickly. So what's going to happen here is the operator is going to put down a set of parts. And when that happens, you see it show up on the right-hand side in our iPad screens. And what the operator does is, and this is taking a use case where the parts may be in multiple different places, or maybe you've had to move the table that has the parts away and you have to move it back. Historically, that's an impossibility. You have to reprogram the entire arm if you want to move anything in the work cell. So here is an example of something that is moved in the work cell. This fixture was not there, and now it is. And just using the cameras and hitting the register button on the camera in the iPad, we now are able to go grab every single one of those parts from the tray, with the cameras actually not even able to see all of the parts. The camera just knows where the fiducial, the QR code marker is, and then it goes and executes flawlessly every single part in that tray. So fast forwarding here. So the next part of this is moving the arm. So you undo the wheels, you move the arm, you go ahead and re-cinch the wheels so that the RMO is firmly planted on the ground. the marker again. And again, if you notice that the accuracy of the placement of the arm, as long as the camera can see that marker, it can be at any angle, it can be as far away as the arm can reach. When you hit that register button, the Rapid AI is making an assessment on whether or not it can reach all the aspects of the work cell needed to deploy the task. And it also is redoing its entire motion path, no programming needed whatsoever, to determine exactly what it needs to do in order to perfectly place this part into the pad printer and start executing. And so you see here, we say it's faster than making a cup of coffee. It actually takes a little longer to undo the wheels and move the robot over to the new machine than it does for the arm to reprogram itself using our AI on how to go produce these parts. And so with that, I will stop there, and looking forward to any and all questions that everybody might have on Rapid Robotics, the machine operator shortages. Any topics are up for discussion.
Great. Thanks, Jordan. Terrific presentation. Learned a lot about robotics and automation, and maybe hopefully that percentage of people that are using robotics will go up a bit in the near future. Let's hope, anyway. As Jordan said, we're ready to take questions. So submit a question. You can email pnevents@crane.com, or if you're watching along on LinkedIn, YouTube, or Facebook, you can send us your question using those methods anyway. First question that's come in: do you need a machine integrator with a rapid machine operator? Do you need to have a systems integrator with this operation with the RMO?
No, absolutely not. So one of the most important things that we've done for all of these deployments is remove the most expensive, the most time-consuming component of using robots, which are systems integrators. And in fact, most systems integrators, they don't want to get engaged in this kind of work. They're looking for bigger projects, which is why they charge so much money to execute these simple projects, where what we have done at Rapid essentially is automate the process of deploying automation by removing the need to do any programming on the arm, by removing and by adding the flexibility of being able, like I just showed, to move the arm yourselves without any programming oversight or expertise between these machines. We've removed the need for the systems integrator, which is a big reason why there's so much profit so quickly, on our system. With that systems integrator model, you're looking at that hundreds of thousands of dollars of cash outlay and 2 to 3 years at minimum to pay back that CapEx expenditure versus the human labor that you had. And with the Rapid system, because we're working at such a low dollar rate, the second it's deployed, the second we show up at your site, deploy the arm and leave, then you are more profitable. You are making more money on that deployment. You're not in the red for 2 or 3 years, which you are with a standard systems integrator. And so that's why it was so important to us to remove that component from the use of robotics, to remove that barrier.
Excellent. Well, that's really a key to the whole system, it sounds like. How long does it take to deploy an RMO?
Yeah, so our customers come to us, and we've had customers with a desperate need. They had 3 operators leave on a critical path program. They needed us to get robots there. From the second they signed the contract, within a few days, we had robots on site ready to work. And then after just a few hours on site for simple integrations. So some of the ones I showed you there are considered very simple, just picking and placing, packing parts, filling boxes, doing, taping things, very simple machine operator things. Those are just a few hours. We have a few deployments that I didn't show examples of that are more complex, where it's multiple robots working together in an assembly line, for example. Those may take 1 to 2 days because there's multiple robots and there's a lot more perfecting to do on that. But our standard deployments are done less than a day. We're in and out of there. And, and typically between 1 and 2 weeks of signing a contract, we have the robots ready to go.
Wow. So very fast anyway, was set up with this.
Lightning speed. Yes.
That's excellent. A question coming in, how does an RMO learn a new task?
So initially, it's a great question. I didn't really talk about the technical side of how we do what we do. So this is, I guess, an opportunity to do that. Our entire AI is trained using synthetic data or CAD files. Because we're working in manufacturing, everybody's got CAD files for everything. We've got CAD files of the machines, CAD files of the parts. We've even got CAD files for the conveyors and any sort of other external automation components necessary. And so with those CAD files, we can create a real world model of what our arm is going to look like in your work cell. And that also trains our AI on what it's looking for. So when our cameras turn on, it's looking for the physical representations of the CAD files. And that's how the arms are programmed, is to look for those CAD files or the physical versions of those CAD files, and then execute their processes based on where and how those parts are oriented. And so, so that's how we program them. And so it's not your standard sort of waypoint by waypoint driven programming. The programming is much more dynamic than that.
Wow. It sounds like you're using CAD files in a lot of cases.
Yeah.
Excellent. Again, to submit a question, you can email pnevents@crane.com, or if you're on LinkedIn, YouTube, or Facebook, you can send a question that way. We have some time left if you have any questions. What type of training is required for my staff to use an ROI?
Oh, an RMO.
ROI. Talk about ROI with this.
Delivers ROI.
Yeah, exactly.
So the training is absolutely minimal. I mean, you can see just from how easy it is to move the robot and then tell it that you're at a new machine, and how quickly and easily it reorients itself and starts work on that new machine. You can see that it's a very simple system to use. So the operator training that we do before we leave the facility is all about things like how to operate it safely, how to make sure you understand how to use the emergency stop button if needed, training them on what edge cases the robot is going to handle. So a part of our AI and a part of why we have those CAD files is to handle edge cases. And what happens if something comes to us that we don't expect? How do we handle that? And then how do we message the operators on how to recover from that if it's something that did stop the arm for some reason? So those are the things that we train on. We also create a set of work instructions that hang off the side of the robot that make it very easy for anybody to look, quick 1, 2, 3, in terms of the work instructions. For example, if the parts are fixtured, how often is the operator coming back to pick up the completed parts and replace those completed parts with new parts that need to be processed through? And then what are the work instructions to do that safely? So those are the kinds of training that we do before we leave the facility. And we'll actually, in the weeks after the deployments, a lot of times there's new operators coming into the mix who might have to be interacting with that robot in some way, shape, or form, whether it's refilling parts or whether it's just working alongside it, that we will come back over time and train all of the operators in the facility on how to work in and with and around the Rapid Machine Operator.
That brings up a question too. You talked about on-site deployment in a lot of cases. And how often do you do that? What's typically done in those kind of activities?
Yeah, so the on-site deployment, what we're doing is we're showing up. When we show up, the Rapid Machine Operator looks what you saw in that video. The table structure, the base, everything is already done. The cameras are on, the arm is on, and we're just rolling that thing up to one of the machines. So let's say, you've engaged us and you have 2 different machines that you want this Rapid Machine Operator to work on. We will bring that, install it in front of the first machine, which is basically we plug it into the IO. We test the cameras, making sure that everything can be seen. We run the exact same program that you just saw in that last video there, where it's just using the cameras to automatically identify the locations of all the parts. And then once we've done that, we run a test. And if it works, we then bring the robot to the second machine where we do the exact same thing. And then once that's done, that robot is now capable of being moved by you without us involved between those 2 machines. And so that's the setup process. And that's why it's so fast is all of the initial setup work and the training of our system has been done at our facility before it's delivered on site to you.
Excellent. Well, a few other questions that have come in. We'll go a couple extra minutes here because we just got a few from the audience who want to answer anyway. That's okay. What's the weight limit on the robot and the effector? How much weight can it handle?
Yeah, so our cobot, the one that all the videos I showed were of our cobot, handles 5 kilograms. And then our industrial robot can handle 7 kilograms.
Excellent. Are the robots dust and explosion risk compliant?
Yes, so they are, and I don't have all of the exact technical specs for every type of chemical or anything in front of me, but we do have that. So we are operating in some different environments. I can tell you that, and so there's also in very dusty or dirty environments, there's dust shields that we'll put on the arm and things like that.
Excellent. Another question that came in via email: do the robots have enough length to reach down into a box that's 3 feet deep?
With an extension, yes. So we have done deployments where we're loading Gaylord boxes that have a pretty deep, on the floor sort of reach. And so just visualizing, I do believe that, it's, between 2 and 3 feet, something like that. We have a number of deployments where we've put really long extensions onto J6 to get extra reach, either down into a box that is on the floor or over off to a wall, or in some cases, like to reach into an injection mold machine that's really deep.
Excellent. And another last question. This one's fairly specific. Can you speak about the ability to place inserts into an insert molding tool, both specifically into a horizontal clamp and into a horizontal clamp machine? Is there anything you can talk about?
So with these kinds of things, it really just depends on the parts. And so the first thing that we do, if there are tasks that you already have in mind, something that's this specific, in a quick 20-minute intro phone call, we take a look with you if you've got pictures or videos of those tasks, learn about your business, first of all, and the kinds of things you're producing. We will take a look at those and make a determination based on a number of different parameters. I mean, it's everything from how close can we get to the machine to, what's the cycle time of the machine? Can we get the parts out of the mold quickly enough before the machine is closing again? There's so many little components that go in. Our team deals with all of that. You tell us what the requirements are, what the parameters are, and we take a look at those. And then we come back to you with a proposal that either says we can roll a robot right up to this and execute it right out of the box, or we need to work with you on an updated process, which might involve like another piece of equipment that's needed in order to help execute the program. And so we make that assessment. We can make that assessment fairly quickly. And so, both our sales team as well as our deployment experts are involved in that process and helping determine the feasibility of each task that we're looking at. And then the other thing after that 20-minute call is a lot of times we'll go do an on-site review. We'll look at not just the task that you might have come to us with, but we'll look at other opportunities around the facility. Because if there's this one, let's say that this task, with the horizontal clamp machine and all of that, let's say that for some reason, whether it's reach or whether it's, just our capabilities not able to do it out of the box or easy enough, we might find, other tasks on your floor. Happens all the time. We'll find other tasks on the floor that actually can free up the same amount of labor that would have been freed up by, putting automation in front of the task that you came to us with.
Terrific. Well, with that, I think we'll end it here. I want to thank Jordan Kretschmer of Rapid Robotics for walking us through our RMO system and how to use some of this in your facility. And great videos too. Sometimes the pictures are worth 1,000 words. In this case, that helped a lot to see it in action. If you have additional questions for Jordan, feel free to reach out to him directly at the email address listed on the screen below, and he'll be happy to answer any questions or talk about specific applications or how your plant's set up with that, those kind of things. Today's Ask the Expert will also be available for viewing on the events section of Plastics News website. I'm Joe Pryweller with the Crane Global Polymer Group. Thanks for joining us today at our Ask the Expert session, and thanks again to Rapid Robotics for sponsoring this session. We'll see you soon. Take care.